Hello everyone, it's June 16th. Uh, yeah, it's June 16th, but actually it's very, very late. I'm at 12 a.m. right now, 12:32 a.m., but I'm still within the within the daily challenge because the LeetCode time is the California time, the West time, so I still have a few hours left. It was a very eventful day. I was supposed to fit some hardware for my research work, which shouldn't take too long. I have only four sensors to fit. I just need to install the software and then configure them. I'd expect like at most 1 hour per sensor would be sufficient. But what is not expected is the sensor assembly had some issues, and there are some wiring that went wrong, and I had to fix. So with each sensor, I had to first take them apart and correct the wiring, put them back, and then install. So this took a long time. I think I started working on this from 3 o'clock, 3 p.m. ish, right? And then I just finished now. So what do we have? Like 9 hours. Maybe a little bit, maybe not. I think maybe 4. Yeah, 8 hours. Yeah, so it took about 2 hours per sensor instead of just one. Very, very frustrating experience. But anyway, we're gonna still do it today. And today, I hope it's not going to be something hard, something that I can just crack it once and then we get it done. All right, let's take a look. Anything here to take care of? I don't think so. All right, hopefully not something too bad. Generate parentheses. Okay. Oh, look at this. Yeah, I cleared my cache, so it shows a C++. I'm not going to write C++. Given n pairs of parentheses, write a function to generate all combinations of where form parentheses. Ooh, 3 pairs. Oh, nice, nice. 1 pair. Okay, let's see. Some type of recursion, that's for sure. And with only 8, that means the runtime can be very bad. I don't care. Okay, let's say 1 pair. Right? 1 pair is this. How about 2 pairs? Well, for 2 pairs, how do you represent 2 pairs? I mean, what is 1 pair? So 2 pairs, that means 4. Right? 8 pairs is 16. Right? 3 pair is 6. Right? 2 to the n. We're going to iterate through all possibilities and then just check which one is valid. That's right. That's how we're going to do it. Yeah, if you think about it, that's how we're going to do it. And we can use 1 is like a bitmap again. I mean, it's just 1 and zeros, right? So let's say if the left parentheses, let's call it a 0. Right parentheses is a 1, right? So with 1, we have 0, 1, right? And then with 3, like, there was 0, 0, 0, 1, 1, 1, right? So basically, we know how to check whether it is valid. So we just list through all possibilities with zeros and ones. I mean, think about it. N is 8, right? N is 8. That means a 16, 2 to the 16th. 2 to the 16th. What's 2 to the 16th? 2 to the 16th is not that big. What, it's like 256, right? It's 2 to the 8th squared. Now 2 to the 8th is 32. 32 squared. No, that's more. 32 squared. What's 32 squared? I said 1024. 32 square. No, I think it's smaller. No, it is 1024. So of 1024, that's the largest. But if we can create the state with a little bit smart, like if we say we do half zeros and half ones, I don't really think that it works that way though. But we can count, right? We can count. And then we can eliminate the cases where they are not half and half. And we'll only consider the half and half. Yeah, let's try it that way. Right, let's try it that way. Alrighty. Alright. I'm gonna have to make it a little bit bigger. It's way too small. That should be good. Maybe just a little bit bigger. Yeah, a bit easier to see on the screen. So, you see the pattern here. If the n is very small, then we can just iterate all possible situations, right? So we're gonna say for p in range from 0 to 1, go n minus 1, right? Yeah. And then you say we need to get a is a binary is bin, right? Bin, let's say 5. That's not the one I want. I want the format 5 and B. Is that 0B? 0B4? Nope. B04. Nope. I forgot. Python binary int to binary. Int to binary. I remember. Oh, I logged out on all my stuff. Oh, I don't have Stack Overflow here. Did I use Google for this? Yeah, I think I used Google for this. There we go. Accept all cookies. Format MB. Format this. Oh, it's 04B. There we go. 04B. Alright, so what we want is the P is this. P binary. P binary equals format P and 0 n B. Of course, n has to be like this, right? So this will get here, and we say if pb.count, right, count 0 is not equal to count 0 times 2 is not equal to len pb. Nah, it's only equal to. Then we do it. Then we check. How do we check? We just in the front we put in a stack. So we say stack equals this. We say for E in PB, right? For E in PB, if not stack or stack at the top equals, and then we say 0, right? 0 is the left parenthesis. So there's left parentheses not stack or stack top, no. If not stack, no. If it's a left parenthesis, we'll always push it in. No. If e equals 0 left parenthesis, then we say stack dot append e, right? Else, then we need to check else if elif stack and stack top is equal to the left parentheses, then we say stack dot pop, right? Otherwise, we can just, otherwise we don't do anything. Otherwise we break. That means it's not a valid. So, right, we break it out and then go to the else. So if we go through everything and we never break, then we say rest.append. Right, so we're going to have a rest here. Rest going to be here, so we're going to append. And what we're going to turn 0. So we can say pb dot replace old is going to be 0. We'll replace 0 with left parentheses dot replace 1 with a right parentheses. And we're going to turn rest. Okay, take a shot. So n is 3, and then this is the answer. I'll probably have to do answer sort as well, just to make sure that it is what we want. So this is just this, right? And we're going to fix all the double quotes, and we'll also fix all this, right? It's going to be n. This is going to be generate parentheses n, and we say sorted rest equals sorted answer. Oh, hold up, replace doesn't return a string. Hold up. Let's say it's going to be 0101. A dot replace 0 with left parentheses. Yeah, it does work. Something is not right. Okay, let's try this. So I have 3, and then let's print PB, see what we get. We have 0, 0, 1, 0, 1, 0, 0, 1, 1. Ooh, that is not correct. Oh, I see. I have to do this. Now we have all the situations, but we have problems. Oh, shoot, it's 2 times. Ha. Oh, hold on. So it's not alright because that has to be 2 times n as well. There we go, now we pass. Okay, so we need 2 times. Yep. Yeah, just taking advantage of the fact. Alright, so can we make this like shorter? We'll do count equals this, then we do, otherwise we don't do, right? And then stack. If it's this, we append. If not, and we have it. that means it's a right parentheses, then we just pop it. Else, that means it's a fake, I cannot do, yeah. I think we can make it even shorter. We're gonna submit this. Yeah, I'll never worry about the runtime as long as it's correct. Judging, accepted. Yep. So since the largest n is 8, which means we have a 16. We have, which means it's the largest, the longest, right? The longest parenthesis string is 16 element. Now we can iterate through all possible parentheses arrangement and then check which ones are valid. The max number of check is 2 to the 16th equals 24 times, which is very reasonable. The check is easily done via stack. So the runtime is 2 to the n for sure, but I think each one will do also a check. This check will happen times, well, it's actually 2 to the 2n, not 2 to the 2n times n. Not if n is when we do this, 2 to the 2n times n. I can call it 01. Runtime of 84 milliseconds. Right, 84 milliseconds. Oh, we have a 6% ranking. Ooh. Seems to me that there are better solutions. Which means we don't go through everything. How do we not go through everything? I mean, I already skipped all the bad ones. I went through everything and I checked, right? I mean, technically, I think we're checking. Yeah, we did check something twice, like 111, say 1100, and the 0011, right? The two are exactly the same thing. And I'm checking them twice. Does that mean we can do better by? Hold on, let me think. That is true, because it would never be 1 something, right? Because you say 1 is a right parenthesis, so the start must be a 0. Right, which means the first position must be a 0. If the first position is a 0, that means we actually can do one length shorter. So it's going to be 2 times this minus 1. Ooh, that is not right. Or I have to be more explicit on this. No, I don't have to. I'm trying to reduce 1. If I reduce 1 in here, but if n is 1, 2 times 1 is 1, and 2 minus 1 is 1, so 1 going left 1 time will give us 1, 0, right? And 1, 0 minus 1 is going to 2 minus 1 will be 1, right? It's going to be 1. So P in range 1, and how? P in range 1, but I already said format, right? Format P is 1, and this is going to be 0 to B. It will be 0, 1, right? It will be 0, 1, and then remember this is correct. So E in PB is 0. If it's 0, we'll have this, right? And the next one E is not 0. If stack, top is 0, stack the top, right? And then nothing coming out. How? How is this one not passing? Right, let's take a look. Same thing, print PB, see if anything came out. We print out 0, 0. Huh. Because we minus 1, it becomes instead of 2, we need 1, right? And then range 1, 1 is not included. Oh, so we need to include. We should include, yeah. We should include. We should include because 1 left shift is the total value, is the value plus 1. Yeah, we should include. That was error to start to start with. That was my bad, but that's the trick. That's the trick. We can make it fast, twice as fast. So run twice as fast. Okay, so we're gonna try this one again. And for this one, we're run twice as fast. I'll say it's twice as fast. And then it's 2 and minus 1. Which means it's divided by 2. Right, and then this one we get to 64 milliseconds, or a 10% ranking. Yeah, we say the first one must be a close parentheses, a left. And the last one must be a right parentheses, right? The last one must be a right parentheses, which means the last one has to be 1, right? Last one must be 1, which means the value must be odd value, right? It must be odd value. So you can say from 1 to this and 2. Alright, let's see if this one can make it even better. Just change this line, submit. Now we're doing all odd numbers. Well, now we have 244. Or 25%. Good. From 6% all the way to 24%. And if we can do it even more, is there any way? maybe we don't check. I mean, technically we don't have to check. We just go through this. Oh, we do have to check. Oh, huh. We can check at the end. Like we go through, that should be the same, right? I can say elif not stack. Invalid syntax. Else, if not stack. I'm not sure. This feels. I mean, we're avoiding a count. Maybe we need to upgrade on this one. A place. Oh. Let's try. Like, if we do this, will we have significant improvement on this? Right. No, doesn't have significant improvement. The last trick I can pull up. Actually, I think this is worse. So yeah, we have stop, pop, and push. Yeah, I think that's worse. Actually, I don't like it. I like to have the check, but I'm try to replace this one. Maybe we can make this part easier. How do we replace this one? We can say, let's say for E in PV, right? For E in PV, and then let's say left parentheses and right parentheses. If E is 0, I'm going to do left parentheses. So we're going to say left parentheses. If E equals 0, else we do right parentheses. Alright, so this, I'm going to say that join. Okay, so let's try this. Actually, we don't know the ranking for this one. So look at improvement. Let's see. No, so that's not. Alright, so we're gonna just keep the replace and replace. Yep. Alright, so this is what I can do. There is one trick on iterating through all possible solutions, all possible parentheses states. Since we designate 0 is going to be the left parentheses and 1 is going to be the right parentheses, then the state cannot start with 1 and cannot end with a 0. Therefore, we only have to iterate 2 to the n minus 1 number of states, and each state must be an odd number. This shrinks our search size, our search space, right? Our search space, which leads to this result, and leads to the for runtime. Okay. And we're doing this, so it's actually even shorter. So it's going to be 2n minus 1, and then we'll also divide it by 2 again. Because we only know, so it actually, I think it's 2n by 2, right? Alright, let's see a solution. I thought I had a solution. Yeah, this feels like an easy question, which is exactly what I need today. Let's consider a medium question. Oh, 22, I have done them before. Let's see a submission. "2018, a long time ago. What was my method in the past? Oh my god. Oh, recursion. I use recursion to do this. Oh. Looks complicated. And then what? And then I have like a slightly better solution. Oh, this one looks easier. Yeah, we should try recursion. So I didn't quite look at it. So how do we do recursion? You can say initially it's going to be a left, right? To have a right, we do a left parentheses, and then on the right side is either a left or a right parentheses. If it's a right parentheses, then the code we can pop it out. We don't need to worry about it. It's only when the next one is a right, see the end. Right, so we start with the left, and if we have a right, immediately that's escape. If we have a left, and we have another left, right? So we have two lefts, and then the next one will be is the same. Like if I'm on left, then I always try to see if the next one is a right. If the next one is a right, then yeah, wait a minute, you're trying to write it out, so it's going to be we're gonna count how many are left, right? So we have a left parentheses, and then so we have two options. We can either write a left or write a left or write a right. Okay. So within each we can check, like if the previous one is a left, then we can always do a left, or we do a right. If the previous one is a right, if the previous one is a right parentheses, what do we do? Well, if the previous one is a right parentheses, it shouldn't be, right? We should not have a right parenthesis. If it's a right, it shall be, every time we have a right, it will be popped out. So it shouldn't be a right. If we have a right parentheses by itself, then that's a no-go. Right? So eventually, we'll reach the end. Right, we'll reach the end. That means we have the total number of parentheses is gone. Then we should have no left parentheses anymore. Yeah, so we have a left, and if I have a right, then what? If I have a right, basically we say keep adding, right? Basically say we keep adding, so if it's a right parentheses, then we have to return to the previous call stack, and we just return, right? We just return, and return a current number. Maybe. Let me try. Okay, so from 2, we'll try recursion ourselves. So for the recursion, I'll call it helper. What do we need? Well, we need what do we need? We're gonna pass in the number to be fulfilled. Right, we're gonna pass in the number to be fulfilled, and then we're gonna return the ones that has been fulfilled. So I say remain, right? So remaining we need to do, and we're gonna return also an int. So what's the end situation? The end situation is you add something, and what's the end situation? The end situation is remaining is 0, right? That means we have done everything. So we say if remaining is 0, then we're gonna have a rest here. Oh, probably need to also. Oh, how do we record? Oh, because we are writing, and every time we find a pair, then we say we're gonna pop it, but you won't be able to know. Or we can just keep building a string. Right? We keep building a string, and then we have index, its current position, and then when we have the right parentheses, we write it, and then we move the left parentheses to a certain position. Right? We move the left parentheses back. Then if it's the left, we keep going. And the left have to move to the new one. No, I don't think this is right. I don't know how to write this in a recursion anymore. Given the left parentheses, I have two choices, either right or a left or right or right. If I write a right, then this pair basically is done, right? But we need to save this. If we don't save this, then okay, that means we need something more, right? Something more, something to save the current state, and the other thing to do the analysis, right? If I save the current state in a certain value and then we do an analysis on the other value, then so it's going to be remaining, right? The remaining is a state. And the remaining is remaining. How many are remain? And then we also need a current state. A state. State is just a stack. Yeah, I think that is just a stack. We just call it a stack. Right? And then we say current str, linear str. So the remaining is 0, right? So we took all of them, and then we need to also check the stack. The stack has to be, if remaining is 0, right? And not stack. There's nothing in the stack. Then we say rest.append current str. Right? Else, if remaining is not 0, right? Remaining is not 0, and then we'll have a stack. Now we have a current str, and current str is the empty string, right? So we always write left or right. If we write left, then we are going to, if we write left, and there's a left blue bag. Oh, I am starting to have a hallucination already. How is the stack keep tracking? Are we doing backtracking? Oh my god. The brain is not loyal right now. Can't figure out the recursion even if I had in the past. No, I don't think this is working. I need to check the solution. That's too late. Yeah, I'm doing brute force. It is backtracking. Closure number. Oh my god. Instead of adding every time, this is minus the closing brackets. Let's only add them when we know it will remain a valid sequence. We can do this by keeping track of the number of opening and the closing brackets we have placed so far. If we have one, left place, and we can start a closing bracket if it will not exceed the number of opening brackets. Oh my goodness, that was so simple. Backtrack. Left, a number of left, number of right. If minus equals this, then we see that's a good one. If left is smaller than n, so we do a left, and then we backtrack left plus 1. If right is smaller than left, then we add a right. Ooh, interesting idea. I'm going to add them when we know it will remain a valid sequence. We can do this by keeping track of the number of opening and closing brackets. We start an opening bracket if we still have one of n left to place. Right, so we say if we have more left to give, so we can always give a left. And we can only add a right if the number of right is smaller than the number of left. If the number of right is equal to, then we cannot give. Right, so we can do that. And then we backtrack it again, and we say s left, and then we do one more right. I think what it's saying is, for a valid one, we always add left first. We always add left, and then we add right. So it'll be like left, 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 all the way left until we cannot add left anymore, then we can add right. Right, so prioritize left, and then we do right. How do we know that the result is going to be valid? If right is smaller than left, so more left than right. So are you saying as long as these two values are the same, and as long as two values are the same, and we have left parentheses to start, and then right parentheses to the end, then you're saying that is going to work? I think this is what it's trying to say. This n is just plus all sequence of length 1, and then this plus all sequence of length n minus 1. All sequences of length n is just left parentheses plus all sequences of length this, and then right parentheses with all sequence of length. That's true, right? That's true. And then we check if valid. Now we'll have to use a stack. Balance plus either 1, else balance minus 1. If balance, yeah, that's the balance. Same concept, but I think balance will be faster, sure. So generate A, pop A, and generate this, and pop X. That's the backtracking. So we can put a left parentheses, and then after we put the left parentheses, when we will generate the remaining. Right? Yeah, it's the same one. We generate the remaining, and then after it's done, we're backtracking, and then we put a right parenthesis, we generate the remaining. So this is to generate every single one. Yes, this is to generate every single possibilities. But then we say, instead of having left and right, to add them when we know it will remain a valid sequence. How is it valid? Well, we add left. We have to add left parenthesis first. Right? We add a left parenthesis because we cannot at the beginning add a right parenthesis. So it has to be left, right? So we add a left, and then after we add the left, we have remaining. So we just need to add a remaining. Yeah, after we add the left, then we add a remaining. And after that, we'll backtrack. and then we can add right. But that's exactly the same thing, but with conditions. See. Oh my god. Alright, the last one. Alright, so before we read the last one, let's say this. I wasn't able to come up with a recursion solution, probably because my brain is tired. Anyway, this is the recursion solution from the official recursion solution. The key observation is that at each step we can add this or either this or this. After that, we have the same subproblem, which can also be solved by asking by adding either a left parentheses or a right parentheses. However, we can make better decisions as to when the left parentheses or right parentheses is used. The solution constraints that the left parent constraints that we can only add a left parentheses when the total number of left parentheses is within a smaller n minus 2. I think it is smaller equal to, which is this one, right? Smaller equal to n minus 2. And the total number of right parentheses we can only add a right parentheses when the current number of right parentheses is smaller or equal to the left. Because if it's larger, right, then we are having a problem. Then we cannot have a larger value in right compared to left, because that is a failed command. When the current number of the right parentheses is smaller or equal to, we cannot have a larger value in right compared to the left, because with this restriction, these add left number is smaller and the current number of right parentheses is smaller than or equal to the left. The Gaussian relation is fairly easy to write. The rest we have helper. So what do we need? We need current potential list, right? List. Then we need to add a number of right. So num right p, num left p, right? So we're going to add a left. Well, we're going to check the ending. So we say if len is equal to 2 times n, then we can just say rest.pan dot join potential list, right? And this one is just going to return null. Well, yeah, it doesn't have to return anything. Else, it's not equal to 2 times. So it's still, in that case, I'm going to say if number of left parentheses already in there is smaller than n divided by 2, right? Smaller than half. Then we can say let's try. We say helper list number right. If number of left parentheses is smaller, we can try. So we say potential list dot hand kind of what? Kind of this. This is what we add, right? After we add, we need to say we pass this number of right p and number of left p plus 1. Number of right plus 1, right? And after we add this, all of them done, we need to say dot pop, right? So we return potential list to its original state. And then we say if num left p is larger than what's on the other end? Oh, we need to add a right parenthesis. And the only way to add a right parenthesis is if the left parenthesis is smaller or equal to the left. Which means if this one is larger than num right parentheses, right? Then we can do the same thing. Pop list dot append. I don't think this will be append. Yes, we're going to add a right parentheses, right? If we have enough room for a right parentheses, we can add it. We have to add it. And the recursion again. Then num right plus 1. Num left stay the same. Okay. So that's the helper. Yep. We'll visit every single one, but with more selection. Right? And then the solution will be, we can call it helper. Initialize empty. Then number of right initial is 0, number of left initial is also 0. I'm not sure. I hope this is the last one we test. I'm very tired now. Oh, syntax error. None type is not a trouble. Where? 84. 84. Oh. We call this and then return this. Well, we fail. Why is that? Well, potential list initially is nothing. And then this definitely is true. No on the panel left. And the helper to add. Yeah. And once we're done, then we return. Well, if this is smaller than the add one, right? This is larger than the add one. Then when you come up to this thing, control list. And we have a come here. Oh, we never come here. Let's figure out something wrong with the recursion. And then we're gonna only use this one. We add this, we add this. Why at the end? A helper again, right? And the helper coming out. Then potential list. This one never gets called, and then I'm gonna do this. And smaller equal to 2. Number of left parentheses smaller to this. Then yeah, I think what would be better is let's do 2 times number of parentheses is smaller the n, right? And then I say I can add this one. It's slightly different. Oh, it's actually 2 times. It's smaller than n, because n is half. If it's smaller than n, then we can add. Now we pass. Yep, now we pass. This is a recursion solution. Total number is smaller than n. Good solution. Alright, I'm now going to read the last one because I really need to go to bed. Oh wow, okay, this so much faster because we don't have to go through as many cases. So this one runs very fast. 36 milliseconds. Okay, that's it. That shall be it. Closure number. Oh wow. That's very interesting. Let's read. Generally, we will like to express it as a sum of disjoint subsets that are easy to count of a valid parenthesis S, a least index so that S0 is valid. Clearly, every parenthesis sequence has a unique closure number, enumerated individually. Twain must be a valid sequence, plus the rest of elements must be a valid sequence. What is the closure number? Sum of disjoint subsets that are easier to count. Closure number of a valid parenthesis sequence S. 0 to S2 times index plus 1 valid. I don't understand. C in range N, or left in range parenthesis C, N minus 1 minus C for right, dot append, format left and right. What's that? Don't understand. But it's again like we generate the left first, and then we generate the right based on whatever happens on the left, and then we're gonna append. I probably take the time to read it tomorrow. Closure. Simple backtracking. Casually DP. Alright, I'm gonna try this, but that's it for today. It's too late. I need to go to bed. Alright, I'll see you guys tomorrow. Adios.